Cleansing agents. In this module, we will be learning about cleansing agents. The word detergent is a general term used to denote a cleansing agent. Two types of detergents, mainly soaps and synthetic detergents, are used as cleansing agents. These agents improve the cleansing properties of water. They help remove the oily and fatty substances that bind dirt and other material to the skin or the fabric. Soaps used for cleaning are sodium or potassium salts of naturally occurring long-chain fatty acids such as stearic, oleic, and palmitic acids. Soaps that contain sodium salts are formed by heating oil or fat of vegetable or animal origin, which is a glyceryl ester of a fatty acid, with an aqueous sodium hydroxide solution. The hydrolysis of oil or fat results in the formation of a mixture of a sodium salt of a fatty acid and a glycerol, as shown in the equation here. As the salts thus formed are used as soaps, the alkaline hydrolysis of oils and fats is commonly known as saponification. In this reaction, esters of fatty acids are hydrolyzed and the soap obtained remains in colloidal form. The soap and the glycerol are separated by adding concentrated sodium chloride solution to the mixture. The glycerol dissolves in the salt solution, but the soap is insoluble and hence floats on the surface of the solution from where it is removed. Glycerol from the solution is recovered by fractional distillation. Potassium soaps, produced by the saponification of fats with potassium hydroxide, are usually softer and more soluble than sodium soaps. Soaps may vary in composition and method of processing. For example, substances of medicinal value are added to medicated soaps. Similarly, glycerol and a gum called rosin are added while preparing shaving soaps. Glycerol prevents rapid drying, while rosin forms sodium rosinate that lathers well. Similarly, laundry soaps contain fillers like sodium rosinate, sodium silicate, borax, and sodium carbonate. Transparent soaps are made by dissolving the soap in ethanol and then evaporating the excess of solvent. Soaps that float on water are made by beating air into them before they are hardened. In preparing soap powders and scouring soaps, an abrasive agent such as powdered pumice or finely divided sand are added, along with builders such as sodium carbonate and trisodium phosphate. The builders enable the soap to act at a faster rate. In preparing toilet soaps, good quality fats and oils are used and excess alkali is removed. Perfumes and colors are added to make them attractive. Soaps are good cleansing agents, but they do not work with hard water. Hard water has high mineral content that primarily consists of calcium and magnesium ions. These ions make the water resistant to soaps. When these ions come into contact with sodium or potassium soaps, they form insoluble calcium and magnesium soaps. thus rendering them useless as cleansing agents. Calcium and magnesium soaps form a white precipitate called scum in water and hinder cleaning by sticking to the cloth fiber, skin or hair, thus preventing the formation of lather. Let us now look at synthetic agents. Synthetic detergents are cleansing agents that have all the properties of soap but do not contain any soap. They are more efficient than soaps as they give foam in soft water, hard water, as well as in ice-cold water. Synthetic detergents are classified into three main categories. These are anionic detergents, cationic detergents, and non-ionic detergents. Anionic detergents are sodium salts of sulfonated long-chain alcohols of hydrocarbons. Treating long-chain alcohols with concentrated sulfuric acid yields alkyl hydrogen sulfate. Neutralizing alkyl hydrogen sulfate with an alkali gives an anionic detergent. Similarly, alkyl benzene sulfonic acids, on being neutralized with an alkali, yield alkyl benzene sulfonates, as shown in the reaction here. In an anionic synthetic detergent, the anionic part of the molecule does the cleansing action. Anionic detergents are used extensively as dishwashing liquids, laundry liquids, and powder detergents, car wash detergents and shampoos, as well as in toothpastes. Cationic detergents are quaternary ammonium salts of amines with acetates, chlorides, and bromides as anions. The cationic part has a long hydrocarbon chain with a positive charge on the nitrogen atom. Hence, these are called cationic detergents. Cetyl trimethyl ammonium bromide, which is used in hair conditioners, is a well-known cationic detergent. Being expensive, their use is very limited. Non-ionic detergents do not have any ions. Therefore, they are resistant to water hardness deactivation. They produce electrically neutral colloidal particles in solution. The reaction between stearic acid and polyethylene glycol to yield a non-ionic detergent can be seen in the equation here. The liquid dishwashing detergents that we use are of the non-ionic types. Their mechanism of action is the same as that of soaps. Non-ionic detergents are excellent grease removers that are used in laundry products, household cleaners, dishwashing liquids, and even cosmetics. One of the dangers posed by detergents is their extremely slow rate of degradability. This is because their hydrocarbon chain is highly branched, which makes it very difficult for bacteria to degrade it. As a result, the detergents go on accumulating. Ultimately, when they reach water bodies, they cause pollution and foaming.